A geometric sequence is formed when each term of the sequence is obtained by multiplying the previous term by a fixed amount. So let's take this sequence here. 2, 6, 18, 54, ... To get from 2 to 6, we multiply by 3. From 6 to 18, we multiply by 3. And from 18 to 54, we multiply by 3. So we're increasing by a factor of 3 each time. Let's take this sequence, 4, 2, 1, a half, ... To get from 4 to 2, we're multiplying by a half. To get from 2 to 1, we're multiplying by a half. To get from 1 to a half, we're multiplying by a half, ... So we're increasing by a factor of a half each time. Every geometric sequence can be represented by t1, t2, t3, t4, t5, ... up as far as tn, where OR is the common ratio. So we're multiplying each term by OR, which is a fixed amount. So term 1 is A, the first term. So term 2 is going to be A multiplied by OR, which is A OR. Term 3 is going to be the previous term, which was A OR, multiplied by another OR, so that gives us A OR squared. Term 4 is going to be the previous term, which was A OR squared, multiplied by another OR, which is A OR cubed. And term 5 is going to be the previous term, which was A OR cubed, multiplied by another OR, which gives us A OR to the power of 4. ... up as far as A OR to the power of n minus 1. So notice that, let's say, for example, term 4, another way to represent this is A OR to the power of 3. And 4 minus 1 gives us 3. And this is the pattern the whole way along. Likewise with term 5. Term 5 can be represented by A OR to the power of 4. And 5 minus 1 is 4. And likewise again, term 3 can be represented by A OR squared. And 3 minus 1 is 2. So that's where the n minus 1 is coming from in our formula. So again, every geometric sequence can be represented by A, A OR, A OR squared, A OR cubed, A OR to the power of 4, ... up as far as A OR to the power of n minus 1. So if we take this sequence as an example, 2, 6, 18, 54, ... up as far as A OR to the power of n minus 1. Two, we just bring down the 2, that's the first term. It hasn't been multiplied by anything. So that's A, our first term. 6 is 2 times 3. 18 is 2 times 3 times 3, which is 2 times 3 squared. 54 is 2 times 3 times 3 times 3, which is 2 times 3 cubed, ... up as far as 2 times 3 to the power of n minus 1. So term 1 is 2, term 2 is 2 times 3, term 3 is 2 times 3 squared, term 4 is 2 times 3 cubed. So if we take this to be our nth term formula, so 2 times 3 to the power of n minus 1, and we replace n with 1 to get term 1, we get 2 times 3 to the power of 1 minus 1. We do the same for term 2. We replace that n with 2. So we have 2 times 3 to the power of 2 minus 1. And we do the same with term 3. So we replace that n with 3. So we get 2 times 3 to the power of 3 minus 1. And we do the same for term 4. We replace that n with 4. So we get 2 times 3 to the power of 4 minus 1. And then we can clearly see where this list of numbers and terms came from. Because 1 minus 1 is 0. So 3 to the power of 0 is 1. Anything to the power of 0 is 1. And 2 times 1 is just 2. So that works out for our rule. And then 2 minus 1 is 1. So this is 3 to the power of 1, which is what we have there. So 3 on its own is really 3 to the power of 1. And then 3 minus 1 is 2. So we get 3 squared, which is what we had up there. And then 3 to the power of 4 minus 1. 4 minus 1 is 3. So we get 3 cubed, which is what we had up there. So the line written in green writing is just showing you where the second blue line comes from. Okay, so we don't need that green line anymore now when we're talking about the rest of the questions. So going back to our original sequence, 2, 6, 18, 54. So 2 is our first term, 2 is A. So A is equal to 2, which is the first term. And then OR, which represents the common ratio, is going to be the second term divided by the first term. So 6 divided by 2, which is 3. And Tn can be written as A times OR to the power of n minus 1. So this is our nth term for a geometric sequence. This is our nth term formula for a geometric sequence, and it's given in the formula book. So the nth term for this particular sequence, so in blue writing, is Tn equals 2 times 3 to the power of n minus 1. And that's given to you on page 22 of the formula book.